hi everyone. Thanks so much for joining today. I can see we've got people all across Europe. So welcome to everyone, wherever you are. My name is Lucy and I'm the Supply Marketing Executive at Distrelec. Today's webinar will be delivered by John Reynolds from Fluke. John is the Technical Sales Manager at Fluke, so he's a real expert. So if you've got any questions at any point, please use the Q&A function at the bottom. We'll try and get through as many as we can. Before I hand over to John, I just want to remind to everyone that this webinar is recorded, so it will be used in future marketing purposes. But yeah, that's everything from me. So over to you, John.
Excellent. Thank you, Lucy. Okay, so we know what we're here for, but I'll just go through a couple of things to start off with. I'm sure most people are aware of Fluke, but I'll go through a little bit about us. We're 75 years old this year, actually. We've got over 1,000 products currently that are in the market being used. Over 3,500 employees. We have operating bases in 39 countries and operate pretty much in every country at the moment, apart from Russia. Currently, we have over 1,845 patents operating and also pending. We're constantly writing some blog articles. You'll see many of our videos for both product and training purposes. Of course, there's a poll come up. We've currently got a lot more than 5 online courses now, and we're actually doing one of our main focuses is to do more on-demand webinars like you're seeing here. So, and of course, my screen locks up there. So we're just going to go through EV testing stations, or testing EV charging stations today. It's not going to be that in-depth, but it is going to give you an idea of the type of things that you might come across, what the pitfalls are, and also what things to be aware of in terms of moving forward in terms of testing, because this is a changing market. So a few years ago, our current energy system would look something like this. So we would have from left to right energy generation through power stations, be it coal or nuclear or gas. That would be then transmitted across regions and countries to substations that would then supply factories and homes in a fairly simple sort of format. Nowadays, that energy system has changed. So rather than just having sort of a single point on the left in terms of energy generation, we've got things like wind and solar being generated at different points in the network. We've also, as we can see, got charging stations because electric vehicles are on the move, and then we've even got things like solar coming in actually at point of supply to energy, be that industrial or sort of domestic. Today we're going to be concentrating on just one little bit, and that's going to be the charging stations. Electric vehicles has been with us a lot longer than we think. The first electric train in the top right-hand corner was actually in the sort of mid to late 1870s, and you'll see things like mobility scooters and electric trains have been with us for quite some time. Obviously, now we're going down the electric route, so you're seeing many more electric cars. And in theory, as we get closer to sort of net zero targets, we'll also have things like trucks that will be electric as well. So how large is the as a whole? You're talking about $457 billion in terms of electric vehicles. That's expected to rise compound growth to 858 billion by 2027. So how big is the EV charging market? Currently, it's valued at $14.49 billion in 2021, and they predict it to reach 128 billion by 2030. So that means that there's going to be a large increase in the number of charging stations out there, and an increased need to install, test and maintain those. So specifically for the European electric vehicle market, how many cars are there currently, electric cars, excuse me, currently in the UK? So we've got about 1.7 million at the moment. Or 1.7 at the moment, and that was so another, you see another 700 have actually come in since 2020, and that's only going to move up with different laws in different countries actually looking to ban petrol and diesel vehicles past about 2030. So currently the EU market for chargers in 2021 is an estimated 375,000 charging stations, and that's fairly up to date at the 4th of November 2022. So where's it going to go? From independent analysis, they're basically saying that from that previous figure, they're going to need 6.8 million public charging points by 2030 to reach the 55% CO2 reduction for passenger cars. This means theoretically, and I do say theoretically, we shall see how the future pans out, up to 14,000 public charging points need to be installed per week between 2021 and 2030 for cars. At the moment, that's just 2,000. That was back in 2021. So that is going up daily, and there will need to be an investment of 280 billion by 2030 to reach these targets that governments across Europe are aiming for. So again, there's lots of investment going into this sector. So yeah, it will. Fluke are going to need to be part of that in terms of the testing and maintenance. And with that in mind, how do we actually maintain and test all of these chargers? This is a quote from local UK standards, but your local standards will be something in the same. Basically, as with any new electrical installation, EV charging points need to be tested in accordance with international and local standards. And as we can see, this would be BS 7671 in the UK, but you would have to refer to your local standards for that. But in all cases, you'd have to be a competent person, whichever country you're looking at. So what tests might be required under local standards? And I say this because obviously different countries will have different standards, but all of our testers will look to basically give you these type of tests. So a visual inspection, continuity of protective conductors, insulation resistance, loop and line impedance, RCD trip tests, function, vehicle state, error handling, communication, mechanical locking of EV plug at the charging station, rotary field phase sequence of output voltage if it's three-phase, and there may be some other tests that are required locally. So one thing we should point out that many people who are interested in this, there is a requirement now to have a 6 milliamp RCD, which is not necessarily personnel, but is equipment based somewhere within that circuit. Because as one of my colleagues said, an EV charging station is basically a posh plug somewhere within the circuit. Before the charging point itself, there needs to be a 6 milliamp RCD. Many EV charging manufacturers are now installing the 6 milliamp RCD in the charger itself. There are two types being used often. One is type A RCD, which will detect issues on the AC side as well as DC, but only up to 6 milliamp. Higher leakage than 6 milliamp DC can fool a type A RCD and potentially stop it functioning as it should. And also type B RCD, if an EV charging station does not have a 6 milliamp RCD installed, then a type B RCD should be used on the incoming supply side. Where exactly on that incoming supply side is a matter of some debate, and different countries will have different expectations, as we've been finding out recently. If a multifunction tester doesn't have the capability to test a 6 milliamp RCD, and those would include something like the older 1663s and 1664s for checking disconnect current, you can use a ramp test using the type B RCD and the 10 milliamp setting, and then use it as a function test. So one of the key products that Fluke do, and to be fair, many other manufacturers do, is basically the interface between the charging point, the plug, if you would like, and the tester. In the case of Fluke, that's an EV300. Some of the key features of this is that it can be tested for possible it can test for possible presence of dangerous voltage against Earth. It can do cable simulation, and obviously all of these products will perform vehicle simulation, because if you don't tell the charger that, or at least pretend that a car is connected to the charger, then you won't get any current and signal through, basically. Testing is in accordance to IEC 6185-1 and 60364-7-722, or for shorthand, international standards. This product, because it's got 4mm banana plugs inputs, is designed to be used with other Fluke testing equipment to provide full access to all testing and fault finding parameters. So if we go further into this, if we look at the top, we can see that we can order for type 2 or type 1 or type 2 chargers. You've got a test cable, and you can see here, I won't bore everybody too badly, but you've got several functions that you can use on this, but bear in mind that this is an interface as opposed to a tester at the moment, and I'll go into what I mean by that later. You've got some basic safety tests and state indicators, and then we're using separate testers to actually test what we're looking at here. So with line L1, L2 and L3 neutral and earth inputs on the FEV300, you can provide full safety installation test using a Fluke 1664 FC. The required testing for AC EV charging station currently, and again, check your local rules, but this is correct as of this presentation. Visual inspection, continuity, insulation resistance, loop line impedance, RCD, and various function tests, as we can see here. So we actually have a solution, an all-in-one solution that involved the 1664 with the FEV300. When you are ordering this, make sure that you get the right adapter to any potential charging stations that you're looking for. In addition to this, because again, as I've mentioned before, we can look at various, not just testing but also fault finding. You can plug an 87V multimeter in, which can be useful. In addition to that, if you're looking for a deeper analysis, we've also got the 125B oscilloscope, field oscilloscope, which can be used again with the 300. And also, we've got basically anything else that will plug into a 4mm banana plug. So I'm not going to bore anybody too badly. So if anybody needs these slides, please take a note of my email at the end, because I don't want to waste anybody's time. But we've got some notes on how you would test charging stations for mode 3. Mode 3 being the most common throughout Europe. Mode 1 being basically plugging into a socket. Mode 2 is more an American standard, but mode 3 is the majority of chargers AC now. Mode 4 would be your DC chargers, things like your Tesla superchargers, which just to be open and honest, we haven't got a solution for at the moment. We are, as Fluke, concentrating on the more common version, which is the mode 3 chargers that you'll see at sort of domestic and business premises. Okay, we can see that that again we're going on about these standards, and the testing procedure for the charging station is it will be done step by step according to country-specific specifications. We also simulate the CP error and P error simply by pressing the respective key on the unit. And last, the condition D should be tested, and this again is used by toggle switches. The FEV 300 measuring adapters thus offers a universal solution for quick and easy testing for functionality and safety. And as we can see there, I know this looks similar, but it is actually a different slide. You can see that you will be looking at identifying what current your charging station will be looking for, and you need to put that into the adapter itself, so that the tester that you are using in relation to that will be looking at the right information. So if anybody needs these slides, please feel free to email me afterwards, and I'll send you the presentation. Not a problem. In terms of notes for the future, currently we are working on products that will be a standalone tester, but obviously with the changing regulations, as I've kind of intimated here, it's going to be quite difficult to keep up with that. But we are looking at something like where what you see here would actually have a screen and move to a single testing station, but that also limits you in terms of the type of testers that you can use along with that. So I've given a basic overview, and I believe that's pretty much it. I'll just take my details, as you can see, are on the bottom right hand side. So if you want to email me, feel free. It's john.reynolds@fluke.com, or my number is there if you do need to ring me. I'll be your point of contact if there are any technical issues after this. And now I'm looking if there are any questions. So I'm looking in the chat, and I don't see that there's any questions. No open questions here. So I'll wait a couple of minutes. If anybody wants to sort of think of any questions, then feel free to put them in the chat or in the Q&A. Okay.
Yeah, so thanks so much, John.
Thank you.
Thanks so much for everyone who's joined today. And we will be sending up a follow-up email in the next few days, which will include a recording of this as well. So you can go back and look back on it.
Okay, thanks everybody for taking the time to speak to me, or to listen to me today.